Hi, we are final year engineering students from SRM Institute of Science and Technology. And for our multidisciplinary major project Batch 14, we have developed a project that pushes the boundaries of traditional construction, a fully functional 3D concrete printer. This is a collaborative innovation between the Mechatronics and Civil Engineering departments, where we have combined precise automation with advanced concrete mix design to bring architecture element to life layer by layer.
A printer uses a 3-axis gantry system, 2 y-axis and 1 x-axis and dual z-axis, allowing us to move custom-built extruder in all directions with high precision. The frame is made up from aluminum V-slot profiles for strength and modularity. The extruder is fed by concrete pumping system developed by our civil engineering team, who also formulated printable concrete mix that maintains flowability while setting quickly. Together, this enables us to print structural forms without any formwork or manual shaping. The printer is based on a 3-axis Cartesian gantry mechanism selected for its simplicity, scalability and effectiveness in additive manufacturing applications. The frame supports motion in X, Y and Z direction and is rigid enough to bear the weight of the extrusion system. The 3D concrete printer is built on a Cartesian gantry type frame with a dual Y, single X and dual Z axis configuration. It provides a working area of 1 meter into 1.1 meter into 0.3 meter. The Y axis uses two synchronized belt drives on either sides for stable movement, while the X axis operates through a central belt drive mounted on a gantry plate. The Z-axis is powered by two lead screw coupled to motors, ensuring uniform vertical motion. Together, these axes enable precise multi-directional control essential for layer-by-layer concrete printing. Electrical components such as stepper motor, drivers, a controller board, and a power supply support the overall motion system. The big tree-tech Octopus is the main controller board for the printer and functions as the core controller of the entire system. It receives real-time motion instruction from the Raspberry Pi and translates them into motor signals, handling the direct coordination of all printer hardware. A Raspberry Pi 4 Model B is used to run Clipper firmware, which performs high-level tasks like motion planning, timing and processing G-code. Clipper processes command from the user interface, handles kinematic calculations and sends movement instruction over USB to the Octopus board. The division of tasks allows for faster, more precise movements and improved print quality. The Raspberry Pi also makes printer configuration and monitoring more convenient through a web interface. The printer uses NEMA 23 stepper motors on all axes due to their high torque output, which is necessary for moving the heavy concrete extrusion components. These motors typically have a step angle of 1.8 degree, providing 200 steps per full revolution, and they operate at a rated voltage of 3.2 volt with a current of 2.8 ampere per phase. The driver a holding torque. The printer uses NEMA 23 stepper motors on all axes due to their high torque output, which is necessary for moving the heavy concrete extrusion components. These motors have a step angle of 1.8 degree, providing 200 steps per revolution, and they operate at a rated voltage of 3.2.
This is the whole pumping unit that we use for 3D printer. Here we have 1 HP motor, and here we have the controller. It will control the whole system. And this auger goes inside the pumping unit, and it will connect to the pump, and also it will connect to the motor. It will propel the concrete downwards, and then here in the bottom we connected the hose pipe, the 3x4 inch of hose pipe. It will take the concrete to a 3D printer.